All right, so we're going to move away from general chemistry.
Yeah.
But we're going to use some of the principles that we learned earlier in general chemistry, earlier today. And, okay. Very interesting molecules there. We're going to move away from that, and we're going to add a kind of another layer on there. We're going to use general chemistry as a foundation for the next module in our course. And so now what I want to do is I want to talk about a very special kind of chemistry. And this is known as organic. Organic chemistry. Now, organic, boy, that's a word that there's a lot of context to that word, right? Mm-hmm. Does anyone know, what does organic mean in a chemical context? Okay, it means it's a chemistry of carbon. Why in the hell do I want to take a class of chemistry that deals with carbon? What do you guys think? Something about life, maybe. Is there something really special about the carbon atom? You know, it won't be in your patho book. You don't have to worry about that.
I don't know, I'm getting this out.
How many valence electrons does carbon have? 4. So carbon can bond to 4 other atoms, including itself. So carbon is really good at participating in covalent bonding. It's really flexible as to what it can bond with as well. So you can take carbon, okay, so here I have carbon with its 4 valence electrons, and I can take another carbon with 4 valence electrons, and another carbon with 4 valence electrons, and these carbons can bind to themselves. And do you see how I kind of have a backbone of carbon here? Carbon is really good at forming a backbone, and then off of these carbons I can have other things bond, like hydrogens. All right. Now, it doesn't necessarily need to be hydrogen, but that, you know, it could be hydrogen. Maybe I could have chlorine bind here. Maybe I could have, you know, something else, a hydroxyl group bind here. So carbon is an essential backbone atom. And there are more potential molecules that have carbon in them than anyone could ever think or anyone has ever thought. We're coming up with new ones every day. So carbon is really good at bonding, and it's really good, like I said, at acting as a backbone. It is a backbone atom when it comes to life. That's why we have a whole section of chemistry that we talk about. Okay, so what I want to do is I just want to start with basic organic chemistry, some basic definitions. And what I'm going to start at is I'm going to start at the basic molecules called the hydrocarbons. The hydrocarbons. And the hydrocarbons are just hydrogen-carbon molecules. They're really simple. And the simplest hydrocarbon, okay, the simplest class of hydrocarbons have one bond, one covalent bond, okay? This is the simplest class of organic molecules, and we call those the alkanes. Alkanes have only one bond in them, okay? So the simplest alkane is carbon with its 4 valence electrons binding to 4 hydrogens, all right? You guys see that okay? So it's just carbon with single covalent bonds to 4 hydrogens, like that. Is everybody okay with that? So that would look like this. This is a carbon, and you've got 4 hydrogens that are bound to it. Everybody see that okay? This is called methane. And you guys have probably heard of that before, right? Methane or methane. Methane is an alkane, and whenever we're talking about organic molecules, ANE, if it ends with ANE, it is an alkane. Does that make sense? So methane is an alkane because it has that ANE in it. And CH4 here, okay, is our basic hydrocarbon, our basic alkane, all single bonds, okay? Does that make sense? That's what we call an alkane. We can also have molecules that involve double bonds, and these are called alkenes. So maybe I will, okay, so 1 bond is an alkane, 2 bonds would be an alkene, okay, an alkene. And an example of that might be, let's do this here. Carbon that is double covalently bound to another carbon, okay? So instead of a single carbon, I have 2 carbons, but they're double covalently bound. So is that a double bond? Yes. So that'd make it an alkene. And then we will have hydrogens coming off of that, okay? We got a molecule like that. That is an alkene, and that molecule is a molecule of ethene. So we have ethene, and what does ethene end with?
Ene.
Ene, right? So if you're reading a book and you're reading about some of these molecules, and it ends with an Ene, without even looking at the molecular structure, you know that it has a double bond in it, because that is what makes it an alkene. An alkane would be a single bond. And then finally, we can also have triple bonds, or 3 bonds. Okay? And we call those alkynes. Alkynes with a Y in it. Okay? And one that I could show you, and you guys are probably might be familiar with this, would be a carbon triple bond to a carbon, and then just a hydrogen that comes off the end of it. All right? So here's a double, here's a triple. Remember, because I have a triple bond, I take away hydrogens, right? See how I'm losing, how I have 4 hydrogens for 1 carbon here, and now I'm down to 4 hydrogens for both, and now I'm down to 2, because all those electrons are here in the bonds. Does that kind of make sense? So you only need those 2 hydrogens to meet the octet rule. Okay, so that is an example of ethine. Ethine. Okay. Ethine, Y-N-E. And again, this, and this is methane, the A-N-E. A-N-E, E-N-E, Y-N-E. There is a unofficial name for this. And does anybody here do any welding? You do welding? Anyone has anyone ever done any welding? Yeah. Do you have 2 types of welding? You have arc welding, right? And what's the other type of welding?
MIG welding, TIG welding.
Well, that's all like arc. You have like arc, and then you have what?
We use gas.
We use gas, right? And what's a common gas you use? Acetylene, right? That's acetylene. That's what an acetylene molecule looks like. So when you combust acetylene and these hydrogen bonds go off, that's what you're doing. Yeah, so ethine is actually, acetylene is a more common name, I guess, for ethine. You guys good with that? So these are the basic classes of hydrocarbons. Now, hydrocarbons are interesting because they're not very polar, okay? They're not polar like water. Water is a very polar molecule. And remember, anytime you have oxygen, blue's nitrogen, you have oxygen, nitrogen, or fluorine and hydrogen atoms, you have polar molecules. Whenever you have hydrogens and carbons, you have non-polar molecules. So polar molecules tend to want to be attracted to each other, and they tend to be liquids at lower temperatures, or at higher temperatures rather. Okay, water can be a liquid at room temperature, right? What do you know about acetylene? What do you know about methane? These are gases at room temperature, aren't they? They don't experience the intermolecular forces that polar molecules like water experience. So they tend to be gases. You have to get them very, very cold to liquefy. Does that make sense? Because they're not polar, and because you don't have significant intermolecular forces. Is everybody okay with there? Does that kind of make sense? So? Okay, I don't want to lose anybody. Most people tend to like organic maybe a little more, at least the way I talk about it, because it's like, oh wow, we get to talk about some molecules. All right. Now what I want to do is I want to talk about, we know about the last part, the suffix, right? Ane, ene, and ine, right? Everybody is okay with what the suffix means, right? What about the prefix? The prefix, like meth and eth, those also have meaning. And the way that this works is, if I have a hydrocarbon with one carbon, only one carbon atom, that is a meth. A meth. All right? Just one. Like this is methane. One carbon, single bonds. Does that make sense? Two carbons. Okay. Two carbons is F. Like ethene, right? Two carbons. Ene is a double bond. Does that make sense? I think it's kind of cool. You can actually just look at the word and start to make sense of what that molecule may look like. Okay? If you have three carbons, okay? You have three carbon. We'll draw it right here. So carbon, carbon, carbon. A three-carbon chain, okay? Okay. Three carbons is prop. Prop. Okay, prop. For example, if I have three carbons and all those carbons have hydrogens like this, you guys see that? Okay. That's propane, all single bonds. Propane, and you guys know propane gas, propane grills, right?
Propane accessories.
What's that?
Propane accessories.
Yeah. The King of the Hill, right? Yeah. You know the creator of King of the Hill? You know where he goes back to? You date yourself. Anyone remember it?
Beavis and Butthead?
Beavis and Butthead. You created Beavis and Butthead before he went on to do King of the Hill. Total useless knowledge. All right. Moving back on. So does that make sense why it's called? So now you know if I say propane, you're like prop. Oh, okay. So that's three carbons, ane, all single bonds. Propane. How cool is that, huh? And then if I have four carbons would be bute.
Butane.
Oh, how about that? Butane lighters, right? Mm-hmm. So all of these molecules that you guys are familiar with, you're like, oh, wow, okay, now I know why they're called what they are. So butane would be four carbons, okay? Heptane would be 5. Hexane would be 6. 7 would be whatever. Octane would be 8. And so on and so forth. The longer your carbon chain, the you know, whatever name would designate that many carbons. I'm just going to cover, you know, up to 4 or 5. But you guys get the point, right? And could I also, let's say, what's this molecule right here?
Carbon.
No, this molecule.
Oh, propane.
Propane, right? What if I did this? What if I did this to this propane molecule here? I maybe got rid of a hydrogen and made a double bond here. What would we call that? Would it be propane anymore?
No.
It would be propene, right? And let's say that I did this here, something like this, and made a triple bond. It would be propine. Yeah.
So it doesn't matter that the other one only has a single bond?
Right. As long as there's just one double or one triple bond in that molecule, it would be an alkyne or alkene.
So it goes on the most aggressive bond?
Yes.
Okay.
So if you look at them all, if it's a hydrocarbon, you look at it. If it's all, it all has every bond has to be a single bond for it to be an alkane. The only thing that would make it an alkene would be one double bond somewhere, in there, and then an alkyne would be one triple bond somewhere. Does that kind of make sense? But we're talking hydrocarbons, okay? So it just is hydrogen and carbon at this point. It can't be any other atoms. If it had like nitrogen or that, it actually wouldn't be a hydrocarbon. Does that kind of make sense? Mm-hmm. So this is just very, very simple organic molecules of hydrocarbons. Now, you guys have probably heard the term saturated and unsaturated. Have you ever heard of that term? Saturated and unsaturated? When we talk about saturated versus unsaturated, I'm going to use this example with hydrocarbons because it's really easy to see. A saturated hydrocarbon, okay, is a hydrocarbon, yeah, this will work, is a hydrocarbon where you have the maximum number of hydrogen atoms bonded to the carbon, okay? Do you see how that's fully saturated? This is what we call a saturated hydrocarbon. But what if I had this with a double bond? What do you have now? This is an example of an unsaturated, okay? Because you don't have the maximum number of hydrogens bonded to that, right? Because you have a second bond there, a double bond, so that takes away. So when you talk about like saturated fats, those are fats where you have these long carbon-hydrogen chains and you have the maximum number of hydrogens in that fatty acid or that lipid. Unsaturated fats are fats, long carbon-hydrogen fatty chains that have double, maybe triple bonds, generally double bonds, and so you lose some of those hydrogens. Does that kind of make sense? So that's what the difference between a saturated and an unsaturated, for example, fat would be. This is just basic hydrocarbons. It's the same idea though. Is everyone okay with that? So saturated versus unsaturated. Okay, good. All right. So we're moving right along. Okay. So now what I want to do is I want to talk about probably one of the more important areas of organic chemistry. And that is a concept known as a functional group. Okay? Known as a functional group. What I'm going to do is is everybody okay with the basic terminology we covered earlier? Sir?
So, the first example, the carbons and the hydrogens, that's saturated.
This would be saturated.
Okay, and then the furthest to the right would be unsaturated.
This would be unsaturated.
So what makes the middle one saturated if there's a double bond with the carbons?
No, there's just a single bond.
Or a single bond, I mean.
Yeah.
Oh.
Yeah, because it's basically for this configuration, for a carbon bonded to a carbon, the maximum number of hydrogens would be present.
Okay, I see what you're
Yeah. So think of it as a potential. You know, if you have 4 or 5 carbons in a chain, what is the maximum number of hydrogens you could have? And if it's not that, then it's considered unsaturated. Does that kind of help?
Yes.
Okay, cool. So there we go. And these concepts will come back a little bit when we get into talking about like lipid membranes and stuff. a little later on in class, and you hear me say, saturated or unsaturated fat, or sometimes I'll even use the term polyunsaturated, and that just means that you have multiple areas of double bonds. But we'll get there when we get there. Okay. So I want to talk about functional groups, and this is where it gets real. It gets really interesting. All right. So what I'm going to do is I'm going to take methane. All right. I'm going to take methane, just a simple carbon. All right, just a simple alkane, right? Simple alkane. And this is what you do. A functional group is a group that you can add onto a hydrocarbon that significantly changes the nature. Actually, it's no longer really a hydrocarbon once you add a functional group. Okay? So
Can you repeat that?
a functional group is a group, it's either an atom or a molecule that you replace one of these hydrogens with. You replace a hydrogen with that changes, it fundamentally changes the properties of this molecule. So what are the properties of methane? If I had to say, what are the big properties of methane?
Gas.
It's gas, okay? Its physical state is gas. It's light, okay? It's combustible, right? But it's gaseous, right? It does not experience significant intermolecular forces. So what I'm going to do is I'm going to talk about the first functional group, okay? The first major functional group. And that first major functional group is a hydroxyl group, okay? A hydroxyl. Okay, that is an oxygen and a hydrogen, an OH. So what I'm going to do is I'm going to take this methane, and I'm going to take the carbon, and I'm going to have 3 hydrogens, and I'm going to replace one of those hydrogens with that OH, the hydroxyl group. Okay? When I do that, I no longer have a simple hydrocarbon, okay? I have turned this into an alcohol. That's what an alcohol is. An alcohol is the addition of a hydroxyl functional group to a hydrocarbon. Okay? So instead of methane, I now have methanol. Meth, okay, 1 carbon, all single bonds, all hydroxyl group. So I have turned my methane gas into methanol, and what is methanol? It's an alcohol, right? It's wood alcohol. What physical state is it in? You can actually find this in a liquid state, right? Yeah, liquid state. And it's kind of toxic too, isn't it? It's very toxic if you drink a lot of it, right? If you drink a lot of methanol, it's considered a toxic alcohol, right? It can cause things like blindness, like damage to your optic nerve and that. It's very toxic. If you breathe in methane, is it particularly bad? No. It might, it could explode, or if it was there was no oxygen around, you'd asphyxiate. But just inhaling, a little bit of methane on its own, not a big deal, right? But it's explosive gas. I add a hydroxyl group and turn methane into methanol, and I have completely changed the physical properties of that into an alcohol. And the reason, why do you think that methanol is now a liquid? What makes methanol liquid?
Hydrogen?
Huh?
Hydrogen?
Well, no, not the hydrogen.
Oxygen.
The oxygen, the OH group, because the OH group is what? Is what? Is polar. Alcohol groups make things polar. So I have added my hydroxyl group here. And remember, the oxygen is negative And the hydrogen is now more positive, right? So that means if I have another one of these guys, see if I have enough, you guys really did a number on these. I'll just show you here. If I have another methanol molecule, oxygen, hydrogen, okay. So I have another methanol molecule. What's going to happen is the hydrogen here is going to be attracted to the oxygen there, right? And you're going to have hydrogen bonding, and that hydrogen bonding is going to kind of hold this together and make this more of a liquid. Everybody cool with that? Does that make sense? How cool is that? How cool is that? So, same rules apply. Methanol, meth is one carbon, right? What's two carbons? Ethanol. So here, so carbon, carbon, hydrogen, 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 hydrogen. That's ethane, right? That's ethane, simple hydrocarbon. I replace this with a OH group. I now have ethanol. What's ethanol? Yeah, ethanol is drinking alcohol, right? And I could do that with three. I could turn propane into propanol. Does that make sense?
Is that why it's ETOH?
ETOH is ethanol. Yeah. ET is ethane, and then OH is the hydroxyl group. And the hydroxyl group is what makes it an alcohol. How crazy is that, huh? ETOH, you're absolutely correct. How crazy. I think that's incredible. That's incredible what just one functional group will do. Okay, so are you guys okay with alcohols? With an alcohol functional group? Okay, alcohol is the addition of an OH or an HO, however one, the hydroxyl group. Okay, and it makes the molecule more polar. All right? You guys cool with that? All right, awesome. Let's now talk about another functional group. Okay? So my next functional group is something known as a ketone group. Okay? And a ketone group is where I have let me get rid of this. You guys okay with all this here? I was just going to wipe these out here and we'll kind of start anew. You guys have heard of the term ketone, haven't you? Yeah, you've heard of ketones before. You've heard of the term diabetic ketoacidosis, which involves a ketone, one major ketone. Actually, I'm going to show you that. So a ketone. Okay, a ketone. What does a ketone functional group look like? Well, a ketone functional group is a carbon double bonded to an oxygen. Okay. That's what a ketone group looks like, this right here. These R's here, when I put an R down, and R just means whatever else, but other stuff. R just means other stuff. Just think of it that way. So there could be other stuff here, but this is what, this functional group here is what makes it a ketone. You guys cool with that? Huh? Yeah, but it has to be other stuff, okay? It can't just be CO at the end of something. There has to be other stuff going on as well. Okay, other stuff on here, other stuff here, and then you have this C double bond O here. Does that make sense?
So the definition is be oxygen double bonded to carbon and other molecules?
Yeah, and then you have other molecules coming off of the other two bonds that carbon could have. So you have 1, 2, 3, 4. 2 of the 4 bonds is to an oxygen, and then the other 2 bonds are to other stuff. Does that kind of make sense? That is a ketone. And an example of a ketone, let me give you guys this here. C double bond O, CH3, CH3. Okay? So this would look like this. Carbon, double bond oxygen, C, C, and then 3 hydrogens coming off of those carbons, like that. You guys good with that? This is something known as acetone. Acetone. O-N-E, O-N-E. Ketone is an acetone. Does that make sense? Okay. And acetone is actually one of the molecules that's present in patients that have diabetic ketoacidosis. Okay, and it's one of the molecules, and occasionally you might even be able to smell it because it kind of has a, they say, kind of a fruity type of smell. I don't know about that. It smells kind of not so good, I think. I think of like juicy fruit gum or something. I was like, it doesn't smell like juicy fruit gum. Her breath smells a little nasty. It's the acetone there. Okay. Acetone is also polar, okay, because I added an oxygen here. Basically, anytime you're adding oxygen stuff, you're going to make things more polar, okay? So you can make this more polar, okay? Acetone. You guys cool with that? Everybody okay? Okay, so that's what an acetone is. And I might as well, since you saw this right here, right? The CH3, I might as well just mention that. A CH3, a carbon with 3 hydrogens attached to R, something else, right? So this is my C with my 3 H's, and then this would be everything else here. This is my C with 3 H's, and then this would be everything else here. This is known as a methyl or a methyl group. A methyl group. Okay? A methyl group, CH3. So alcohols and ketones tend to make molecules more or less polar. More polar. Alcohols and ketones tend to make molecules more polar. What do you think methyl groups do? Less polar, right? Carbon-hydrogen bonds. Anytime you have lots of carbon-hydrogen single bonds, you have molecules that are tend to be more nonpolar. So you can add methyl groups to molecules to make them less polar, or you could add alcohols or ketone groups to make them more polar. Does that make sense? And that's how we can modify a lot of our drugs. For example, everybody knows what amphetamines are, right? You know, amphetamines are sympathomimetic drugs, right? And they affect the dopamine, the dopamine systems in your brain, and increase your levels of catecholamines, epinephrine, and that, right? And you know the side effects. Well, what I can do is I can take an amphetamine and I can add a methyl group to it and make it methamphetamine. And that means that it's less polar. And you guys don't know this yet, but now you do. Non-polar molecules tend to pass through membranes much easier than polar molecules. So what I've done is if I make my amphetamine molecule less polar, methamphetamine, it's going to want to go through membranes and it's going to get into my brain much easier than amphetamine. So it's going to have more potent effects. And don't we see that? If you take amphetamine like Adderall or something like that, okay, you've seen people that take Adderall, things for ADD, ADHD, and then you see people that take things like methamphetamine, they tend to act a little differently, don't they? The people that are taking methamphetamines can be really aggressive and can have lots of issues, right? Methamphetamines are highly potent, and part of the reason they're so potent is because we attach a methyl group to those, and they are less polar, and they can interact because our cell membranes contain fats, which is something we'll talk about in a bit, and fats are nonpolar. And so nonpolar molecules can go right on through membranes that are fatty, get into your brain. Does that make sense? So functional groups fundamentally change how our drugs work too, and how some of the medications that you guys will be administering work, or already administer.
So what's the prefix?
Dex?
Hmm?
Dex? Like as a kid, I used to take Dexedrine for these.
Yes, I'm getting there. Don't steal my thunder. Okay? Forgetting you even said Dex. I want to hear it. But that is a great question, and it has a very good meaning. It's a little complicated, but we will get there. I promise you, I won't forget that. It's actually in the notes. Okay, you guys good with that? So alcohol groups, ketone groups, methyl groups. Okay. We also have what are called aldehyde groups. Okay. Aldehyde. So this is a ketone. Aldehyde is going to be very, very similar to a ketone. Aldehyde. Okay, an aldehyde is an oxygen double bound to a carbon with R and just an H. So this R becomes an H. Does that make sense? So a ketone is, this is all kinds of stuff. An aldehyde, you only have one R and it has to be an H. Okay, so O double bond C single bond H R group. Is everybody okay with that? That's an aldehyde. So aldehydes tend to make things a little more polar, would you agree? Because I have an oxygen here. So I tend to make things a little more polar. All right, an aldehyde group. An example of an aldehyde might be, oh yeah.
Aldehyde?
Yes. C double bond O H H. Okay, so this R just happens to be an H in this case. That is formaldehyde. Okay. Formaldehyde. And then when formaldehyde is dissolved in water, okay, so you have H2O. So here's an O, H, like this, and water dissolves formaldehyde, we call that formalin. So when formaldehyde dissolves in water due to hydrogen bonding, we call it formalin. Is everyone cool with that? And you guys are probably familiar with that because that's one of the major ways we involve people, right? Right? They use a formaldehyde and you mix it in the water, it becomes a formalin. Formalin is just nothing more than a mixture of water and formaldehyde. Okay? So that's an aldehyde. All right. And then finally, well, not finally, but we have another group called a carboxylic acid. So this is a functional group that tends to make things more acidic, right? And a carboxylic acid, or a carboxyl group, is a kind of alcohol. Okay, so carboxyl group is a COOH. I just look at it like that, COOH. You remember COOH, that'll kind of get you in the right direction. So it is a C, double bond to an O, OH with an R. Okay, so the only difference between an aldehyde and a carboxyl is this H is an OH, and this R can be whatever else is there. Does that make sense? Okay, an example, and carboxyl groups tend to be acids. We call them carboxylic acids because what happens is, if this gets put into water, say, if this gets put into water, so here I have my H2O molecule, this hydrogen tends to fall off of the oxygen and become a proton as it's attracted to the oxygen, and then that's negative there, keeps the electron. And remember, what is something that donates a proton?
Hydrogen.
Is an acid, right? Yeah, a hydrogen ion. Yeah, this is an acid, and then the water accepts that proton. You see how that works? Everyone okay with that? All right. So this is a carboxyl group. And what would be a good example of a carboxyl group? Something simple. Oh, yeah. Let's do this. COH. All right, that's vinegar. Acetic acid. Okay, that's just vinegar. All right. So that'd be an example of a carboxylic acid. All right. All right. You guys okay? So? Okay. Cool. Okay, we still have a little time. We'll be able to get through all the functional groups. So the next group is an important group, and this is called an amine group. Okay, an amine group. An amine. And an amine group is a functional group that contains nitrogen. Okay? So you can have nitrogen with 2 hydrogens and then whatever else like that. Okay, you can have that. You can have R, N, H, R like that. Okay, so something else, the nitrogen, hydrogen, and then something else. Okay, that is also an amine. Or you could have R, something else, nitrogen, and then whatever else. Okay, you could have a chain of carbons and so hydroxyl and a chain of carbons here, whatever else. So all 3 of these are examples of amines. Okay. Amine groups are very important when it comes to building specialized molecules like genetic molecules, DNA and RNA. Okay, you need to have amine groups for them. And they're really important when it comes to steroids and neurotransmitters. There is a large group of what we call sympathetic agents. And those sympathetic agents are known as Catechol Amines. Okay? And the basic structure of a catecholamine, okay, is something that looks like this here. We'll draw it down here. I'll try to make it large for you guys. All right. Here. Okay. Looks something like this. All right, and then I'll fill the hydrogens in. Put a line here to separate that. 1, 2, 3, that's okay. And then that's topped with a methyl group there. Okay? So where's my amine group at? Right here, right? Would you guys agree this is my amine group? Okay, this is actually a molecule of epinephrine. Okay? And then this right here is called a catechol nucleus, or another name for this is a benzene or aromatic ring, which is the last functional group we'll talk about. And an aromatic ring consists of 5 carbon atoms. Okay? And the interesting thing about it is the bonds alternate between double and single bonds. That's known as resonance. There is a resonance structure to that. So what I will do is I will make you guys that, and then I'll pass this around so you all can take a look at what I mean between the alternating single and double bonds.
Is that 6?
Or 6, I'm sorry, 6 carbons. My bad. Yes, you're absolutely correct. 6. I said 5, didn't I?
Yeah.
No, 6. Sorry about that, guys. It's a 6 carbon ring. Yeah. Smart ass. It's all good. It's all good. There's always got to be that one guy, little micromanager. I'm just kidding, man. It won't be the first time. It won't be for the first time that it's probably not the first time you corrected me, and it certainly won't be the last. So, all right, there we go. Okay, so this is what a benzene ring looks like, and it's double, single, double, single, double. You see that? And you also have to fill in the oxygen or the hydrogens. So there are hydrogens attached to this as well. I just don't have enough to fill in, but you have to use your imagination. Wherever the octet isn't met, there'll be a hydrogen. So there'll be a hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, okay? Can you use your imagination, just pretend that there are hydrogens where they need to be? Can everyone do that?
Yes.
Tough if you can't. I'll pass that guy around. This is a benzene ring, okay? And benzene ring this is the symbol for benzene ring, and occasionally what we'll do is we'll do something like this, okay? And that just means double, single to symbolize that it is a resonance. Or sometimes, instead of the double single, what they'll do, what you'll see in the textbook, is just a circle. Sometimes they'll just have a circle. That means the same thing. You guys okay with that? So I have my amine here. Okay, nitrogen, hydrogen. So do you think an amine makes it more or less polar?
Less.
Well, remember I said, what are the most electronegative atoms?
Oxygen.
Nitrogen, oxygen, and fluorine, right? And whenever hydrogen is bonded to nitrogen, oxygen, fluorine, it's very polar. So this tends to make it more polar. But what do you think that benzene ring does? Do you think that benzene ring makes it polar or non-polar?
Non-polar.
Yeah, it's a lot of carbon and a lot of hydrogen bound together, so benzene rings are non-polar. Okay, so that's a lot of stuff we just went over, isn't it?
Mm-hmm.
Okay, a lot of stuff. So let's just recap.
Chemistry is the
Yeah. What's chemistry? Okay, alcohols make it polar. And what kind of functional group is an alcohol? An OH, hydroxyl. Okay. Ketones make it polar or non-polar?
More polar.
Polar. Ketone, we got it there. Methyl groups, polar or non-polar?
Less polar.
Non-polar, right? Aldehydes,
More polar.
more polar. Carboxyls,
More polar.
benzene,
Less.
non-polar, okay? So, make sure you know which ones are polar and non-polar. Methyl groups, okay, methyl groups and benzene rings tend to make it non-polar, okay? The more of those you have, the more non-polar your molecule is going to be. Does that make sense?
The carboxyl was non-polar or polar?
Polar, right? Because these become acids even. Yeah, the OH. Huh? Yeah, I have an oxygen here and an oxygen here, yeah.
So more polar.
More polar. So basically, all the functional groups with the exception of methyl groups and benzene rings, or aromatic rings, make our molecules polar, right? Those two functional groups make it non-polar.
Amine group does as well?
Amine makes it polar, because remember, amine is nitrogen, and remember I said whenever hydrogen is attached to a nitrogen, an oxygen, or a fluorine, it's going to be very non-polar, or very polar, excuse me. Now you guys got me all confused.
We're confused.
Is that totally clear as mud?
Yes.
Okay. So, benzene rings make it what?
Less polar.
Non-polar. Carboxyl groups. Aldehyde groups. Ketones. Amines. All right. Alcohols.
Polar.
Methyl groups.
Non-polar.
You guys got it. Hooray. Yeah. All right. Take a break. Get out of here.